So the structure questions related to topic covalent bonding. The diagram shows electron arrangement in a molecule of ammonia, showing the outer shell electrons only. As you can see, that's state the type of bonding in ammonia. So what kind of bonding? Because there is a sharing of electron. Whenever there is a sharing of electron, that bonding is known as covalent. Or if two non-metals are involved, that also known as covalent. Hydrogen, which is N2H4, is another compound of nitrogen and hydrogen. Complete the diagram to show the electron arrangement in a molecule of hydrogen. So we check the group nitrogen, it belongs to group 5. As it belongs to group 5, how many electron it will share? It will share 3 electron, and how many unshared will be there? 2. And hydrogen, it is group 1, it will share 1 and unshared will be 0. Whenever we start the sharing, we start with a surrounding atom, the one which share the least number. So if hydrogen share 1, nitrogen from that side will share 1. Same thing, hydrogen share 1, nitrogen will share 1, hydrogen share 1, nitrogen share 1, hydrogen shares 1, nitrogen will share 1. So total number of electrons which hydrogen should share, that's 1, that's done. But total number of electrons which each nitrogen should share, that's 3. But we only share 2, that is 1 and 2. So the third one will be between the two nitrogen atoms. So this is a shared pair of electron between them, and then we have to draw the two unshared electron. So each nitrogen will have two unshared electrons. So this is a structure of N2H4. In question 2, silicon 4 oxide has a giant structure which is similar to that of diamond. Name the type of bonding present in between the silicon atoms. Because it's a covalent, or basically they ask not silicon 4 oxide, they mention silicon having the same structure as diamond. So what if diamond is having a covalent bond and silicon, we know it is a non-metal. So between the non-metal atom, what kind of bonding will be there? This is known as a covalent bonding. Suggest two physical properties of silicon. Use your knowledge of the structure and bonding. Explain why silicon has these properties. So they give you the answer in the question. They mention that silicon has a giant structure and it has similar structure to that of diamond. So the properties of the diamond matches with the properties of silicon. So if I say it is having a high melting point, the property I can say it is having a high melting point. Melting point or boiling point refers to force of attraction between the particles. So you can mention that strong bonds are there between the atoms. That's why it is having a high melting point. And how I predict that it will have a high melting point? Because they mentioned it is similar to that of diamond. That's why all the properties of the diamond will match with the silicon. Then does not conduct electricity. So if I mention that it does not conduct electricity, so what I can say? I can say there is no free electron, that's why it does not conduct electricity. So there is no free electron or charge to move, that's why it does not conduct electricity. So in the giant structure, the force of attraction between the, like, what is the difference between a simple giant structure and the molecules? When you have, say, a simple molecule or simple covalent, like carbon dioxide. So this is one molecule of carbon dioxide. This is another molecule of carbon dioxide. So between the molecules, there is a force. This force is having a specific name known as a van der Waals force, but that is always weak. Yes, to conduct electricity, there must be a charge or there must be electron to conduct electricity. But what about the giant structure, giant covalent such as diamond, silicon 4 oxide? So they all have covalent bond with each other, and covalent bonds are stronger. That's why it will be difficult to melt the substance. The bond between the atoms, this is representing the bond between the atoms. So bond between the atoms, because in a giant structure, there are covalent bonds between the atoms, and covalent bonds are stronger, and it is a big structure. That's why it will have a high melting point. But for a simple covalent substance, this is a bond between the atoms. This is a covalent bond. But between the molecule, there is no strong force. That's why they have a low melting or boiling point. So simple covalent have low melting point, whereas giant will have a high melting or a boiling point. In question 3, a carbon dioxide. So carbon dioxide is gas at room temperature. So what does it means? We know carbon is non-metal, oxygen is non-metal. So between the atom there will be a covalent bond. But because they will have molecules, so between the molecules the force will be weak. Whereas silicon 4 oxide is solid. So even though it is also a non-metal, but this will have a giant structure. So within the giant structure, all the covalent bonds are there. So they have high melting point. Name the type of structure which the following compound have. Carbon dioxide, so type of structure, it will have a simple covalent. And silicon 4 oxide, it will have a giant covalent. Then use your knowledge of structure and bonding. Explain why carbon dioxide is gas at room temperature. So why carbon dioxide is gas at room temperature? Between carbon and oxygen, there is a covalent bond. Yes, you can write macromolecule as well. That's true. Giant covalent or macromolecule. So this force will be weak. So simple carbon dioxide, it's of 3 marks. So how you score 3 marks? But in silicon 4 oxide, it will have a giant structure in which all the bonds are covalent bond, and it will be strong covalent bonds, giant or the macromolecular structure. So when we write the answer, we will mention that carbon dioxide having weak force between the molecules, whereas silicon 4 oxide or silicon oxide having strong bonds or covalent bonds in a giant structure. That's why silicon 4 oxide is solid. And what will be the third mark? Because if a strong attraction is there, you need more force. If weaker attraction, it means less force or less energy. So in case of carbon dioxide, I'm writing at CO2. need less energy to break the bonds. And silicon 4 oxide, SiO2, needs more energy to break the bonds. So these are the points you should write. It's of 3 marks. 1 mark is for mentioning that there is a weak attraction in the molecules of carbon dioxide. Second mark for mentioning that between the molecule or between the atoms of silicon 4 oxide there is a covalent bond which is strong. That's so 1 mark is for mentioning carbon dioxide is having weak bond. The second mark is for mentioning silicon 4 oxide is having a strong bond. And the third mark is for relating the energy, because if bonds are weaker, you need less energy. That's why low melting point or it will be gas. If bonds are stronger, you need more energy or you need high energy to melt the substance. That's why it will be solid. Is it clear, this part? Yes, Abdullah.
Sir, but in point two, we are talking about the force between the molecules. But in point two, we are talking about the force between the atoms.
Because what happened, Abdullah, like because silicon 4 oxide is a giant structure. Like this is one molecule of silicon 4 oxide, okay? But what happened? This molecule is connected with another molecule by a covalent bond. Then this part, this oxygen is also connected with another molecule by a covalent bond. Then this oxygen is also connected with another molecule by a covalent bond. That's why I use the term that atoms, or you can mention that between the two atoms or between the two molecules, there's a covalent bond. That's why it is stronger. Is it clear?
Yes, sir.
So basically the idea is that in carbon dioxide molecule, like this is one molecule of carbon dioxide and this is another molecule of carbon dioxide, but these molecules are not connected by any covalent bond. They have attraction because they have nucleus electrons, so they have attraction, but that is the weak. But what happened in silicon 4 oxide, like this is one molecule of silicon 4 oxide and this is another molecule of silicon 4 oxide. So how they are connected with each other? They are connected with each other by a covalent bond. That's why I use the term that between the atoms there is a covalent bond. You can write that between the molecules there is a covalent bond. It will also give you, or you will also get the marks for that part. Carbon dioxide is gas and its bond. Basically, you have to justify that why carbon dioxide is a gas and why silicon 4 oxide is a solid. So when something is a gas, it means it will have a weak force between the molecule, and something is solid, it means it will be a strong force. And weak force, it means less energy is needed. Strong force means more energy is needed. So you cannot write first that carbon dioxide is a gas, then it's a weak. That's why it's a weak force. You have to say that because there is a weak force, that's why it is gas at room temperature. Then question 4, silicon 4 oxide and sodium chloride. So silicon 4 oxide is a giant. Sodium chloride is ionic compound. Have different types of bonding and structure. Name the type of bonding. So they will have covalent, and between metal and non-metal it will be ionic. You can mention giant covalent or covalent. Name the type of structure present in silicon. So you can write macromolecular or you can mention giant covalent. Silicon 4 oxide is having a high melting point. Explain why. The same reason you will mention silicon oxygen, like the molecules are bonded or molecules have covalent bond between them which is strong, so need more energy. That's why silicon will have a high melting point, silicon 4 oxide. And silicon 4 oxide is a poor conductor. Why it is a poor conductor? Why it does not conduct electricity? Because there is no free electron or ions. It does not have free electron, it does not have ions. That's why it does not conduct electricity. Sodium chloride does not conduct electricity. The solid sodium chloride does not conduct electricity. However, it conducts electricity in molten form. In melted form, it can conduct. So why sodium chloride does not conduct electricity in solid? So reason why it cannot conduct electricity in solid state, because in a solid state, ions are not free to, ions can vibrate, but they're not free to move from one place to another. So positive, negative, and so on. So in a solid state, ions are there, but they are not free to move. But when you melt it, when you melt the substance, now the ions have space, they can move. That is why if ions have space, they can move in a molten form or a melted form. That's why it can conduct electricity. So you cannot write electron here. Why you cannot write electron? Because it is an ionic compound. Ionic compound does not have electrons. They have positive and negative ion. As the sodium atom loses electron, chlorine gain. So sodium will get a positive charge and chlorine will get a negative. So for ionic compound, why they conduct electricity, you cannot write electron. It should be the term ions. Electron is a term which you can use for metals. Then we have to complete a structure of a molecule. So carbon belongs to group 4. It will share 4 electron and unshared will be 0. Oxygen belongs to group 6. So it will share 2 and unshared will be 4. And hydrogen is having 1 electron and unshared will be 0. So each carbon, you start with hydrogen. So if hydrogen share 1, carbon share 1 from that side. So first we complete the sharing of hydrogen. That is done. And it's easy to understand, like a single line means there should be 2 electrons here. Double line means there should be 4 electrons. So between the 2 carbon, there's a single line, so there should be 2 electrons, 1 from each. Then 2 lines are there, means 4 electrons, so 2 from each carbon and 2 from oxygen. And this is a single line between carbon and oxygen, so there should be a pair of electron between them. And now to draw the unshared one, so 1 2 3 4 for oxygen and 1 2 3 4 for oxygen. So this is a structure of ethanoic acid. So when there is a single line, it means there's a pair of electron. A single line, a pair of electron. Single line, a pair of electron. But when there's a double line, it means 2 pairs or 4 electrons will be there. Complete dot and cross diagram to show the arrangement of electron in molecule of hydrogen sulfide. So sulfur belongs to group 6. It will share 2 electron and unshared will be 4. And hydrogen will share 1 electron and unshared will be 0. So if hydrogen share 1, sulfur will share 1 from that side. Hydrogen share 1, sulfur will share 1 from that side. So sulfur 2 are already shared, hydrogen, each hydrogen shared 1, and then we have to draw the unshared electron for sulfur, 4 unshared. So this is a structure of hydrogen sulfide. Then they are saying hydrogen sulfide is a simple molecular structure. Why hydrogen sulfide is having a low boiling point? So again the same reason why it is having a low boiling point, because this is one molecule of hydrogen sulfide. This will be the another molecule of hydrogen sulfide. So between the molecule, there will be a weak force. And when there's a weak force, we need less energy. That's why it is having a low boiling point. Like because attraction is weaker, so we can break the bond easily. And the last question, complete dot and cross diagram to show electron arrangement in a molecule of ethyne, which is, so as you can see, there's single line. So if there's single line, it means I will draw a pair of electron between the atoms. Triple lines, it means 6 electrons, 3 from one and 3 from other. Why I'm using the same symbol? Because two atoms are same, that's why I'm using the same symbol for their electron. And then there's a single line, so a pair of electron will be there. And we know carbon belongs to group 4, so it will share 4 electron and unshared will be 0. Hydrogen is having 1 electron and unshared will be 0. So this is a structure of ethyne. So this was a weekly homework related to topic covalent bonding. Any question or a doubt related to this part?